Okay, so this is Math 158, section 0.3. This is the first section of the semester, and what we're going to do is we're going to start today by looking a little bit of algebra type review, looking at the distributive property, factoring, expanding, and how to getting prepared for the first unit of this course, which is functions. Again, the course is called Functions, Graphs, and Matrices. We will do 4 units. The first unit is about functions. The second unit is about graphs. The fourth is about matrices. And then the third, we get into some application of these things in the area of finance. So hopefully you've already watched the introduction video that I have provided explaining a little bit about me, my course, and how I expect this course to run. So if you're watching this video, listening to this video, you have found this on Blackboard, and you are watching this, it is expected that you're going to be working on the practice problems as assigned through WebAssign as well, in order to demonstrate the fact that you've learned, practiced, mastered these concepts. So let's begin by looking at the distributive property. Okay, we've got the rule up here of the distributive property, and what it is. It says that if we take A, we multiply times the quantity B plus C. We multiply the A times the B, giving us AB. We multiply A times C and giving us the AC. So let's do number 1 a little bit slowly here. We're going to multiply 5 both times the X and times the 2. Okay. Hopefully you've also found that I have posted a blank copy of these note guides on Blackboard that you can use to follow along as well. Take your own notes, and I'll give some time, pause, and give you some time to practice as well. So when I multiply 5 times the X, I have 5 times X, plus, and then I have 5 times the 2 is going to be 5 times the 2. And so notice that the 5 is being multiplied both to the X as well as to the 2. 5 times X is 5X, and 5 times 2 is 10. And there we have the expansion of 5 times X plus 2 is 5X plus 10. In number 2, same thing, 3X times the X squared plus 3X times, 3X times the negative 5X. And so we have 3X cubed minus 15X squared. And there we have that expansion. Okay. Now in number 3, rather than just having a constant like 5 or an algebraic term like 3x, instead of having a single term multiplied to the 3x and the negative 4, we have the quantity x plus 2 times the quantity 3x minus 4. The way that we're going to handle that is we're going to take the x and distribute the x to both the 3x and to the negative 4. So the x times the 3x is 3x squared. X times the negative 4 is negative 4x. Now when I distribute the 2 to the 3x, that's 6x. 6 times 2x, 2 times 3x is 6x. 2 times the negative 4 is negative 8. The other thing we're going to do here is we're going to always, every time, we're going to look for any like terms that we can combine. And notice we have the negative 4x and the positive 6, and they will combine to give us a 2x. So 3x squared plus 2x minus 8. And there is that expansion. So number 4, similarly, okay, got a little crazy. So x squared times x will give us x cubed. X squared times 1 will give us x squared. 5 times x is 5x, and 5 times 1 is 5. We're going to look in here looking for any like terms, x cubed, x squared, x 5. There are no like terms, and so we're just all set right there. Number 5, again, we have x plus 3 times x plus 5. So we're going to distribute the x to both the x and the 5, resulting in x squared plus 5x. 3 times the x is 3x. 3 times the 5 is 15. Okay. So x squared plus 5x plus 3x plus 15, the 5x and the 3x are like terms. So we can combine those and have x squared plus 8x plus 15. Pay attention, please, particularly to number 5 and number 6. In fact, I would encourage you at this point, pause the video and try number 6 on your own. I'll give you a minute. Okay, I'm assuming that you've paused me. You tried number 6. So in this expansion, x times x squared, x times negative 8 is a negative 8x. 2 times x is a positive 2x. 2 times negative 8 is a negative 16. Negative 8 and a positive 2 is a negative 6x minus 16. Okay, and we have our expansion. Number 7 looks a little bit scarier, but only because instead of having the binomial x minus 5, two terms within there, being multiplied times a binomial, so notice number 5, we've got 2 terms multiplied by 2 terms in the parenthesis. Here in number 7, there are 3 terms in the second parenthesis. The wonderful thing about patterns is you can just simply extend them, and that's what we're going to do here. We're going to multiply x times x squared is x cubed. X times negative 4x is negative 4x squared. X times 7 is 7x. Okay. Now we're going to take the negative 5 and we're going to distribute. I'm going to change colors here because I want to show you something. We're going to do negative 5 times the x squared is a negative 5x squared. Negative 5 times negative 4x is a positive 20x. Negative 5 times 7 is a negative 35. Now we're going to go in here, we're going to look for like terms. And you'll notice that we can find the x squared terms, the negative 4x squared and the negative 5x squared. We can also find the 7x and the 20. And I can go in here looking for like terms. And so this is going to yield for me x cubed minus 9x squared plus 27x minus 35. And this method works, okay? But look at number 8, where I have these 3 terms. I'm going to have a longer line of terms where I'm looking for like terms. And it's going to be a little harder to match. So what I want to do is I want to back up here. Okay. When I move on and do negative 5 times the x squared is negative 5x squared, I can go ahead and put that term underneath the x squared column. Negative 5 times a negative 4x is a plus 20x. Negative 5 times 7 is a negative 35. The only difference here is I'm adding my terms vertically as opposed to horizontally. So now I've already got my like terms combined. X cubed, negative 4x squared minus 5x squared is a negative 9x squared. 7x plus 20x is a plus 27x minus 35. I kind of like that method a little bit better because as I go, I'm combining my like terms. Or I'm not, maybe not combining my like terms, but I'm at least arranging them together. Okay. In number 8, I'm going to use that same method, right? So number 8, x squared times 2x squared is 2x to the 4th. X squared times a negative 5x is negative 5x cubed. X squared times 3 is 3x squared. I like using my colors, so let's change colors again. 3x times 2x squared is 6x cubed. 3x times negative 5x is a negative 15x squared, and 3x times 3 is 9x. Now I'm going to move on to that third term, that negative 5, and do the same thing. I'm going to distribute it to each of these terms in the second parenthesis. So negative 5 times 2x squared is a negative 10x squared. Negative 5 times negative 5x is a positive 25x. Negative 5 times 3 is a negative 15. Now I'm going to now that I've got this lined up, I can add my like terms. And you'll notice that I've got my x cubed terms lined up, I've got my x squared terms lined up, I've got my x terms lined up, okay? And so this just simplifies things quite a bit. So 2x to the fourth plus 1x cubed, right? Negative 5x cubed plus 6x cubed is 1x cubed. 3x squared minus 15x squared minus 10x squared is a negative 22x squared. 9x and 25x is a 34x minus 15. If I take steps like what I'm doing there to line up my like terms as I produce this, it's just a little bit simpler. I'm arranging things neatly so I have a little bit less work later on. Okay, next page. One reason that I wanted to review distributing, the distributive property, is because a very important skill in math that we're going to need in this course is the ability to factor. Rather than doing 3 times 5 is 15, we're going to be asking the question, what numbers can I multiply together to get 15? And that would be 3 times 5. Okay, so you'll notice, suppose we have the expression 3x squared plus 6x. The question is going to be, what algebraic expressions can you multiply together to get a product of 3x squared plus 6x? In other words, what factor is common to both 3x squared and 6x? Well, you'll notice if I can factor a 3x out of each of those, right? So 3x squared plus 6x, they both have a 3x in common. From the 3x squared, I can divide out that 3x and I'd be left with x. And from the 6x, I can divide that by 3 and I would be left with 2. We're undistributing. We're taking that 3x back out of each of those two terms and we can factor that. We're kind of going in reverse. Okay? So in number 9, we want to look at what factor divides evenly into both 6x cubed and 4x squared. From the 6 and the 4, I can take a 2 out of each because 6 and 4 are each divisible by 2. And then from x cubed and x squared, I can factor out, I can divide out x squared, right? Expanding, what we are distributing is multiplying, factoring is dividing. I'm going to divide out. So if I divide 6x cubed by 2x squared, what's left? 3x. And I can ask that either way. 6x cubed divided by 2x squared leaves me with 3x. Or, what would I need to multiply by 2x squared in order to get the 6x cubed? 3x. Okay. So, if I factor or divide 4x squared by 2x squared, I'd be left with 2. Okay, so I've factored this out. And one thing you can always do is a check, right? This is as a check yourself. This is not part of doing the problem, but to check yourself, right? So this is the correct factorization. But what I can do to verify that is I could redistribute 2x squared times 3x and the 2x squared times the 2. Does this give me the original problem back? If the answer is yes, then you factored correctly. So let's look at number 10, 10x cubed minus 5x squared plus 15x. First start with the number, the coefficient. Is there a value that divides evenly into 10, 5, and 15? And the answer is yes. 5 divides evenly into 10, 5, and 15. What about the x cubed, the x squared, and the x to the first? Well, I can take out x to the first. A little hint here, look for the lowest exponent on the x. So 10x cubed divided by 5x is going to leave me with 2x squared. Negative 5x squared divided by 5x is going to leave me with a negative x. 15x divided by 5x is going to leave me with 3. And so that's been factored. Again, if you want to verify your solution, if you want to verify your factorization there, all you need to do is to redistribute 5x times the 2x squared, 5x times the negative x, 5x times the 3 to verify that you do get the expression 10x cubed minus 5x squared plus 15x back. Okay. So number 11, 2x squared y plus xy squared minus x squared y squared. Notice we've got the coefficient 2, 1, and 1. So there's not going to be a number. There's not going to be a coefficient that will divide into each of those. But notice that each term does have an x, and each term does have a y. If I divide 2x squared y by xy, I'm left with 2x. In other words, if I multiplied xy times 2x, I would get 2x squared y. If I divide xy squared by xy, I'd be left with just y. And negative x squared y squared divided by xy is just a negative xy factored. Number 12, number 13. I don't know if you've already looked down toward number 13. Okay, both number 12 and number 13 are not nearly as complicated as they appear to be. And I like to kind of like go beyond and show you some things that look like we're extending something, it's extending an idea or concept. But really, even though they may look scary, they're not nearly as scary as they at least first look. Number 12, what I watch a lot of students do is say, well, what I want to do is I want to expand x cubed and 2x squared and 1x and plus 2, and then do this expansion over here and get all these terms and find out what that expansion is, and then look for like terms, combine them, and then try to factor. I've got a much better solution here. Suggestion. Notice that in this first expression here, the x squared plus 1x plus 2, as well as in this second expression here, there's an x squared plus 1 and an x squared plus 1. There's an x squared plus 1 in each of those. Okay? There's an x squared plus 1 in each of those. So I can actually factor out, let's clean that up. I can actually factor the x squared plus 1 out of each of those terms. When I factor the x squared plus 1 out of this first term, I'm left with x plus 2 minus, and I take the x squared plus 1 out of here. See, those both divided out of there, and I'm left with x plus 3. Okay, so now inside that bracket, x plus 2 minus x plus 3, the x minus x are going to cancel, and then 2 minus 3 is negative 1. And we could even write that as negative x squared plus 1. So that factored a lot quicker, and a lot easier, and a lot cleaner than I was thinking it might based on how messy it looked. So I'm going to do the same thing with number 12. Okay. Notice that in number 12, we have x squared minus 1 to the 5th here, x squared minus 1 to the 6th there. X cubed plus 1 to the 6th, x cubed plus 1 to the 5th. So I've got both in x squared minus 1, some of them, and x cubed plus 1, I got some of them in each of those first two terms. So I've actually got several things I'm going to walk here. First, I'm going to look at the 12 and the 18. Is there anything I can factor out of both the 12 and the 18? And the answer is yes. From both 12 and 18, I can factor out a 6. If I want to, I can leave myself some space in a bracket, maybe a parenthesis. I think I'm going to want a bracket just in case. But if I divide 12 by 6, I have 2. And if I divide the 18 by 6, I have 3. So I'm doing pieces at a time. Now, let's move on. I've got x and x squared. From x to the first and x to the second, I can factor out an x. Now, x divided by x is just 1. I don't need to write the 1 in here. I can, but I don't have to. And then x squared here divided by that x is just going to leave me x. Now notice I have x squared minus 1 to the 5th, x squared minus 1 to the 6th. I can factor out x squared minus 1 to the 5th. So all 5 of these come out here. 5 of the x squared minus 1 to the 6th come out here, and there's 1 left here. Also, x cubed plus 1 to the 6th, x cubed plus 1 to the 5th, I can factor out, whoop, that's crazy. I can factor out x cubed plus 1 to the 5th. So if I take 5 of these 6 and put them here, there's 1 left in here. And all 5 of these came out to here. So at this point, what I have is 6x, x squared minus 1 to the 5th, x cubed plus 1 to the 5th. And then what's going on in here is 2 times x cubed, 2 times 1, 3x times x squared is 3x cubed. 3x times negative 1 is a negative 3x. Now what I want to notice is I have those two like terms. One last step, 6x, x squared minus 1 to the 5th, x cubed plus 1 to the 5th, and then now 2x cubed plus 3x cubed is 5x cubed minus 3x plus 2. Okay, a lot better than trying to expand that out. Okay. Now, where are we going to use these? How much are these going to be used? What is the general purpose going to be? So something that gets used a lot in algebra type classes in this course is that we explore these functions that are called quadratics. A quadratic is an expression that's in the form ax squared. So I have a squared term, that's a quadratic term, plus bx plus c. Okay, that would be a quadratic expression. Notice number 14, we've got 1x squared plus 6x plus 5. So we have a quadratic. Now what we want to do is we're going to practice factoring quadratics. Let's revisit this example here, x plus 3 times x plus 5. Okay, so let me move over to the side just a tad. X plus 3 times x plus 5. If I expand that, remember what we're going to get. X times x is x squared. X times 5 is 5x. 3 times x is 3x. 3 times 5 is 15. X squared plus 8x plus 15. Now, if you look back and you pay attention to where things come from, where did the 8 come from? I got the 8x by adding 5x and 3x. I added the 5 and the 3. 15 came from multiplying the 3 times the 5. In other words, what I can look at is that 15 is a result of multiplying 3 times 5. 8 is a result of adding 3 times 5. So let's suppose that I'm starting with x squared plus 8x plus 15. And I want to refactor that down into a product of two binomials because quadratics, right? This is a quadratic. Quadratics can normally, not always, but normally be factored down into the product of two binomials. So what I'm going to say is if we were to distribute this, where did the x squared come from? The x squared up here, this x squared came from doing x times x. So where is this x squared going to come from? X times x. Now what I want to simply look for is I've got a positive 15 and a positive 8. What two numbers can I multiply together to give me 15 that add together to give me 8? And those answers are 3 and 5. Because 3 plus 5 is 8. 3 times 5 is 15. Now, don't sweat this, because what some people will say is, well, wait a minute. I was going to say that the two numbers that multiply to 15 that add to 8 are 5 and 3. What if I list those two terms in opposite order? It doesn't make any difference. You're multiplying them. And remember that order of multiplication doesn't matter. So x plus 3 times x plus 5, x plus 5 times x plus 3, either way. So beginning with number 14, if we're going to factor this quadratic, what we're going to look for, since it's a quadratic, I should be able to write this as the product of two binomials. And I want to look for the factors of 5 that add up to 6. What two numbers can I multiply together to get 5 that add up to 6? First of all, don't forget it's x and x. Well, the two numbers that multiply together to give me 5 that add to 6 are 5 and 1. Done, factored. Okay. In number 15, what are the two binomials that I can multiply together to get x squared plus 6x plus 8? Well, first of all, to get the x squared would have been an x times x. What are the factors of 8 that add up to 6? Something you can do is, let's take the 8. What two numbers multiply together to give me 8? 1 times 8, 2 times 4. And I think those are my only options. Which set of factors will add up to 6? Well, the 2 times 4. X plus 2, x plus 4. There you go. Now pause the video and try number 16. So hopefully you tried number 16. We want to find a product of binomials. Okay. What's the product of binomials? So what I'm going to do is say, well, to get the x squared, I need x times x. Then I need to find the factors. Sorry about that. Now I need to find the factors of 36 that add up to 15. Again, I can take 36 and list the possible factors. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Which combination of factors will add up to the 15? Well, that's the 3 and 12. So x plus 3 and x plus 12. Factor. Number 17 is similar, except that you'll notice that there's a negative sign in there. Okay, so we're not going to sweat that, right? So the two binomials are going to be x, right? Because to get the x squared, x times x is x squared. 16. What are the factors of 16? 1 and 16, 2 and 8, 4 and 4. Now, we want the product of the two numbers to be a positive 16, but the sum of the two numbers is negative. So each of those numbers would be negative, because negative 1 times negative 16 is a positive 16. Negative 2 times negative 8 is a positive 16. Which combination will add up to negative 10? That would be the negative 2 and the negative 8. And there's the factorization. I can keep doing this all day, right? Number 18. Two binomials. To get the x is x times x. Factors of 20 are 1 and 20, 2 and 10, 4 and 5, and I think that's it. We want the product to be a positive 20, but the sum to be a negative. So both signs are going to be a negative. Which combination, negative 1, negative 20, negative 2, negative 10, negative 4, negative 5, which combination adds up to a negative 9? That would be the negative 4 and negative 5 and factored. And like I've mentioned before, I've not said this in a little bit now in the video, but like I've said before, feel free to verify that you've factored it correctly by expanding. X times x is x squared. X times negative 5 is a negative 5x. Negative 4 times x is a negative 4x. And negative 4 times negative 5 is a positive 20. Combining my like terms of the negative 5x and the negative 4x, you'll notice that factorization, you get the original quadratic back. Okay, so an option there for checking your work. Now, when we get to number 19, things change a little bit here. maybe a little bit more than a little bit, maybe a little bit significant, you'll notice that we don't have a single x squared. So in this parenthesis here, okay, one of these is going to be an x and the other is a 2x. So that's something I'm going to want to be careful of. To get 2x squared, I'm going to multiply 1x times 2x. It also means that with my factors of 12, I'm not going to look for factors of 12 that add up to 11. Okay? What I'm going to suggest that you do is list out the factors of 12, 1 and 12, 2, 6, 3, 4. Okay, and given the remote situation, given the video if we're in class, something else I might be able to show you a little bit different that's easier when you can ask questions and that sort of thing and get some feedback. But the best way I'm going to show you at this point is to try them. Okay? You're going to try the 1 and the 12, the 2 and the 6, the 3 and the 4. And here's what I mean. So for example, let me just start with the 3 and the 4. What if I try plus 3 and plus 4? Okay? Really, I don't need to factor. I don't need to, it's called a little bit of guess and check. I don't need to check that x times 2x is 2x squared. I set it up to be that way on purpose. I don't need to check that 3 times 4 is the 12 because with all of the combinations, that's going to happen. You've set those things up. What it is that we need to look for is will x times 4, which is 4x, and 3 times 2x, which is 6x, does that add up to 11x? No, it adds up to 10x. So that tells me that 3 and 4 is not the right combination. Now, the other thing to be careful of is plus 3 and plus 4 is not the right combination, but what if I tried it the other way around? In this case, notice x times 3x, I'm sorry, x times 3 is 3x, x times 2, 4 times 2x is 8x, and those two do add up to the 11x. So that tells me that my correct combination here is, goodness, my pen's going crazy. My correct combination here is x plus 4 times 2x plus 3. So when that leading coefficient is not 1, we do wind up with a little bit of guess and check. Let's try a couple more. 3x squared minus 10x minus 8. So my two binomials here, one of them is going to have an x and one of them is going to have a 3x. Okay, and if you did it in reverse and you wrote 3x here and the x here, it doesn't make any difference whatsoever. Taking my constant, the negative 8, what are the factors of negative 8 that add up to negative 10? Well, my factors of 8 are 1 and 8, 2 and 4. But what I might want to consider is that it's either a negative 1 and a positive 8 or a positive 1 and a negative 8. Negative 2 and a positive 4, positive 2 and a negative 4. Okay? And then, bad news here, I'm going to double check. I'm going to check each of these. Okay, now I'm going to look ahead and say I know that I want my sum to be a negative 10. Okay, so I might start with these guys here, because if I multiply 3 times an 8, I'm going to get a 24. That's going to be tough, right? So let's just try the negative 2 and the positive 4. If we expand that, here's a positive 12x and a negative 2x. That's a 10x. I got 10x. I want a negative 10x. That's a really good clue that really what you should probably do is just change the sign on each of those. Try a positive 2 and a negative 4. Right? Negative 12, positive 2x is a negative 10x. And so that tells me that that's going to be correct. Okay? So there is a guess and check type scenario. There's no way around it. Okay. Well, a couple ways around it, but not something I'm willing to pursue at this point. Via video. 6x squared minus 13x plus 6. Okay. This one, actually, let me show you. Let me show you the other avenue that you can pursue here, right? So with 6x squared, if I set up my binomials here, it can either be an x and a 6x or a 2x and a 3x. And now I'm getting into more and more guess and check. Maybe this will be helpful. I'm going to show you this once. You can watch it again and again in the video if you'd like. We're looking for that binomial there, right? What I can do is do 6 times 6 is 36. And instead of looking for the factors of 6 to add up to negative 13, I can find the factors of 36 to add up to negative 13. Well, my factors are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And like we said before, since I want a positive 36, but the numbers need to add up to a negative 13, these would all be negative, right? Which is the combination, this one. Now I can't write negative 4, negative 9 like I did before, and the reason I can't is because this leading coefficient here is not 1. So let me take my negative 4 and my negative 9 and divide them each by that leading coefficient, 6. Notice I have negative 2/3 and negative 3/2. You ready? 3x minus 2. 2x minus 3. And there's your factorization. You want to see that again? Let me show it to you one more time. Go back to number 20. If I do this with number 20, I would do 3 times negative 8 is a negative 24. I would look for the factors of negative 24 that add up to the negative 10. 1, 24, 2, 12, 3, 8, 4, 6 are my factors. Now, since I want my product to be negative, one of these values has to be positive and one of them has to be negative. Since I want a negative 10, I would want the larger number to be negative. And the combination that's going to work here is 2, negative 12. Because 2 times negative 12 is negative 24. 2 plus negative 12 is the negative 10. If I divide the 2 and the negative 12 both by this 3, that leading coefficient 3, notice that I will get 2/3 and I'll get negative 4 over 1. Look at what my products are. 3x plus 2, 1x minus 4. Okay. It's a nice little way to not have to do all of the guess and check. Okay, it's not something I'm going to hold you super accountable to this course, but it is something that you can use. Okay, why do I do this factoring? Why do I do all of this factorization? What's the purpose? So the reason that we want to do this, okay, is because what we're going to need to do is we're going to need to solve quadratic equations. So look at number 22. Suppose what we have is x squared plus 6x plus 8. And we need to find what values of x will make this equal to 0. Now, we've already, earlier, right, that x squared plus 6x plus 8 looks familiar. Let me go. Yes, look at number 15. Let me leave this page right like this for a moment. Okay. We've already factored x squared plus 6x plus 8 over here in number 15. Okay. So, again, since this is a 1x squared, x times x would give me the x squared. What are the factors of 8 that add to 6? They were 2 and 4. Now, what's different now in number 22 is that I'm going to say that that product, x plus 2 times x plus 4, equals 0. Okay. Now, here's the magic of 0. If you multiply two numbers together to get 0, one of them has to be 0. So, if x plus 2 times x plus 4 equals 0, then either the x plus 2 has to equal 0 or the x plus 4 has to equal 0. If I subtract 2 from both sides here, x equals negative 2. If I subtract 4 from both sides, x equals negative 4. So, if x squared plus 6x plus 8 equals 0, then either x has to be negative 2 or x has to be negative 4. And those are your two solutions. There's two solutions. You can write it x equals negative 2, negative 4. Either way that you want to write your solution is fine. Okay? So number 23, I'm going to factor this again. And again, this one looks familiar. What are the two factors, right? If for x squared, I need an x times an x. If I multiply two numbers together and get 36 that add to 15, they were 3 and 12. So if x plus 3 times x plus 12 equals 0, then either the x plus 3 has to equal 0 or the x plus 12 has to equal 0. So x is either going to equal negative 3 or x is going to equal negative 12. I prefer to write this as x is negative 3 or negative 12. The comma does mean or. Okay. Now in number 24, I don't want to solve it this way. Okay. Two numbers that multiply together to give me 35 could be 1 and 35. They could be 5 and 7. They could be 70 and 1/2. Really what you want to do is you want to subtract that 35 from both sides so that you have x squared minus 2x minus 35 equals 0. This is something, one of the many things that makes 0 different from all of the other values, okay, is if I multiply two numbers together and get 12, the two numbers could be 1 and 12, 2 and 6, 3 and 4. There's a whole lot of different combinations. But if I multiply two numbers together to get 0, well, then one of the numbers has to be 0, regardless of what the other number is. So, if I multiply two numbers together to get x squared, it would be x times x. What numbers multiply together to give me negative 35? Or what are the factors of negative 35 that add up to negative 2? It'd be a negative 7 and a positive 5. So either the x minus 7 equals 0, meaning that x would be 7, or x plus 5 equals 0 means that x would be negative 5. You notice I'm starting to skip a couple steps, right? I should be able to just finish these steps out. 25 is going to look a little bit different because there's no constant term, right? I don't need to factor the quadratic. I just have the two terms, x squared minus 5x. What can I factor out of each of those two terms? I can factor an x out of each of those terms. X squared divided by x is x. Negative 5x divided by x is negative 5. And so x times x minus 5 equals 0. So either x equals 0 or x minus 5 equals 0. So x is either equal to 0 or 5. Okay. Two more problems left, I think. Yeah. So number 26, right? 2x squared plus 11x plus 12 equals 0. So one of these factors is going to be an x. The other one's going to be a 2x because x times 2x is equal to 2x squared. Remember what we did before is I'm going to multiply 2 times 12 is 24. And I'm going to look for the factors of 24 that add up to 11. They are 3 and 8. If I divide them both by 2, I have 3 over 2 and I have 4 over 1. So my factors here are 2x plus 3 and 1x plus 4. And those are my factors. But that equals 0. I'm not done yet. So either the x plus 4 equals 0 or 2x plus 3 equals 0. Subtract 4 from both sides and x would equal negative 4. 2x plus 3, so 2x equals negative 3, right? If 2x plus 3 equals 0, 2x is negative 3, so x would be negative 3 halves. And so my solutions are x equals -4 or x equals -3 halves. Okay, and I really think that this is the best way to write your solutions. Last problem, very similar. First, remember the first thing, what just happened? The first thing you want to do sorry about that. First thing you want to do is stop fighting with the program. Is you want to subtract, let's write that a little bit better. You want to subtract that 15 from both sides. Okay. We okay here? We're still fighting. So 6 times -15 is -90. I'm looking for the factors of -90 that add up to a +1. I'm just going to tell you they're going to be -9 and 10. -9 times 10 is -90. -9 plus 10 is 1. If I divide each of those by the 6, I get -3 halves and I get 5 thirds. So my factors are going to be 2x minus 3 and 3x plus 5. So if 2x minus 3 equals 0, x would be 3 halves. If 3x plus 5 equals 0, x would be -5 thirds. And so my solutions are 3 halves and -5 thirds. By the way, if you're paying attention, okay, we said way up here, right? -9 times -9 times 10 is my -90, and they add up to. So if I divide by 6, I get the -3 halves and the 5 thirds, right? Notice that I took those, found my factors, set them equal to 0, solve for x, and the solutions that I got are the opposites of those. That's just a little sneaky pattern that is true all the time. You don't have to use it. You do need to be able to factor and solve for x. Okay, so there's section 0.3. Make sure that you do the problems that were assigned in WebAssign to go along with this assignment.